All right, let's try this one without talking about the current and the potential difference. Let's just look at the resistance. Okay, it says find the total resistance. Now, what do I do? Remember, look for the most complex part or the one that looks most difficult, hardest one, and simplify it. So over here, I have this part over here that's in the main path. This is in parallel. But inside this parallel arrangement, I have these two which are in series. And this, these two are in series. Does that make sense? Right? This plus this. Right? If I just see this as one big thing and this other thing, these two are in series. All right, so what can I simplify first? Well, clearly, this one over here, I can combine these two, R3 and R4 into one, right? So I know that this over here would be equivalent to, so if I just look at this over here, I know that I can say that these two are in series, right? So I'll say that this is going to be resistors in that parallel arrangement, which are in series, sorry, RPS. The resistors, which are in the parallel arrangement which are in series, will be equals to the total resistance will be 5 ohm plus 5 ohm equals to 10 ohm, right? So I do know that this is 10 ohm, this is 10 ohm, and this, they are in parallel. So let's find the total resistance of this whole thing. So look at it again. So 1 over Rp, which stands for these resistors in parallel arrangement, will be equals to 1 over 10 plus 1 over, what's this equals to? Like we said just now, 5 plus 5, correct? That gives you that. And the answer will be 2 over 10. Now, question yourself, is this total resistance in my parallel arrangement? No, it is not. Because what you were looking for is 1 over Rp. It will be very helpful if you keep writing this part over here to remind yourself, this is not my final answer. I still need to flip it, right? So I do not want 1 over Rp. What I do want is Rp. So what's Rp equals to? Rp will be the flip, will be 10 over 2, which is equals to 5 ohm. Nice. So what I have so far is I've simplified this into one resistor, right? Which is worth 5 ohm. And now that I have this as just one resistor, because all of this is equal to 5 ohm, right? So this and that, they are in series. And therefore, what is my total resistance? I'll say 5 ohm, which refers to this one over here, plus 5 ohm, which is what I found down here. This is my effective resistance of everything in parallel over here. Therefore, this is equals to 10 ohms. All right, so let's take a look at this part over here. I'd like you to take note that this is the only chapter in physics, I think one of two, that it will be helpful to leave it in fractions first. To leave in fractions first. All right, just because you're going to take the reciprocal, just because you're going to just flip the whole thing over, it's helpful to remain in fractions first. Now, later on, you may see that the numbers are not so perfect. Okay, so let's say if this was a 2 over 11, let's just say 2 over 11, right? 1 over Rp is 2 over 11. It's easy to find Rp because it becomes, flip it, 11 over 2. That you will still need to use decimal place. No fractions allowed for final answers. Okay, hope that makes sense. All right, so that's just for resistors. Let's now play around a little bit when we are talking about, hey, I'm also going to give you my potential difference, my EMF, and the currents. So in this circuit over here, we see that I have a power source, and that's 40 volts. The EMF is 40 volts. And then after that, I have three resistors. I have R1, which is 5 ohms, R2 and R3, they are both 30 ohms, and these are in parallel. And so the question is this. Okay, so usually it's structured this way. They ask you first, can you please tell me what is the current going through R1. What's the current here? After that, then final question asks you, then tell me what is the potential difference across this resistor? Now, how do you do that? All right, so some questions to ask yourself. I1, is this current in the main path or in the split path? Oh, it's in the main path. Okay, so what I know, to find the current in the main path, I would need to know what's the potential difference and resistance, correct? Main path. Oh, that means I need to know what formula. What's the formula I must remember? V equals to IR. If the I over here is the current for the main path, that means I would need to know what is the EMF in the whole thing and the total resistance, isn't it? How do I find that? Okay, well, do I know the potential difference across the whole thing? I do, right? That's here. That's my EMF. That's 40 volts. Great. Do I know the total resistance of the entire circuit? I don't. I don't. So therefore, what I must do is I need to find my total resistance. Now, one of the methods you must remember is that you will always be looking at my formula and ask myself, do I have 2 out of 3? 2 out of 3 because there's 3 over here. Do I have 2 out of 3? Now check it out. I do not know my I, correct? I don't have this. Do I have this? Yes, I do. That's the total that's the total potential difference or the total EMF, right? Do I have this? I don't have it. Oh wait, I can find it because I can just find the effective resistance of this whole thing, which is this and these two. Do I do 5 plus 30 plus 30? No, I can't do that. That would mean it's in series, but it's not. This is in series with the combination of this. It is not in series. R1 is not in series with R2 and R3. No, it's not. Let's be clear. R2 and R3 are in parallel. So what I need to do is I need to find what is the total effective resistance of this parallel circuit. And then when I find that effective resistance, which is like to make this whole thing into just one resistor, then I take this and the effective resistance of this. Those are in series. All right, so let's try to find my total resistance. I'm going to write it in a long line instead of breaking it down, just because this is what you expect to see when you go into O levels, right? So what is my total resistance? My total resistance would be 5 ohm, which is this, correct? Plus whatever this is worth, correct? Now, what is that worth? Now, I do remember one thing. I do remember that I can find the total resistance of that. Total resistance becomes 1 over. You understand what the 1 over is, right? Because it's 1 over RT equals to 1 over R1 plus 1 over R2, right? So putting the 1 over is basically doing this. Okay, can you see that? So 1 over, let's put our 1 over R, wait a minute, not R1, R2. That's the formula, but here this is R2, correct? Plus 1 over R3. What does that equals to? Let's not put the 5 over. Let's put the ohms in. 5 plus 1 over 1 over, this is 30, plus 1 over 30. Nice. What does that equals to? 1 over 2 plus 30. Now, if you use your calculator, right, and then you press 1 divided by, they put 2 over 30, right? 1 divided by 2 over 30. The calculator gives you a very nice number, and that is going to be 15. Now, without using calculator, right, what does this become? What happens when you flip 2 over 30? It just becomes 30 over 2. You see that? It's a flip. Flip everything below it. Right? If you're not comfortable with that, just use your calculator. Your calculator, you should put something like 1 divided by 2 over 30. Right? So this gives me a fantastic number, 5 plus 15. My total resistance is actually 20 ohms. Fantastic. I know my total resistance and I know my EMF. So that means I is equals to, what if I find I? V equals to IR. I is equals to V over R. V over R. My V is 40, my R I found is 20, and that gives me my final answer. Hey, 2 volts. Correct? No. Current is amperes. 2 amperes. Fantastic. All right. So now I know that my current here is actually 2 amperes. Great. How on earth does it help me to solve this over here? Hang on. So I need to know my potential difference across here. Correct? That's my V3. That's the last part of the question what they're asking me for. So again, do I have 2 out of 3? What do I know that's 2 out of 3? Hey, wait a minute. I have R. I know my potential difference across the entire thing is 40. See this thing over here? I don't have current, correct? For this, I'm looking for this. I only have resistance, I don't have current. Correct? My current is not 2 amperes because that's in the main path. Once it splits, it will be something else. Correct? Now, I'm sure now you can roughly tell that, hey, if this is 30, this is 30, right? It should split evenly. If this is 2, this will be 1, 1. But I'd like you to try it this way because you're not going to get this perfect split all the time. Let's do it this way instead. Okay? Check this out. Huh? So, I know I have an R, I have my I can find V. Because I remember that it splits this way, right? V1. And then after that, my V, I'm going to put V2. I'm going to put the V across my parallel circuit. Now, these two, V1 plus Vp, will equal to 40. All right? So, if I can find V1, oh dear, sorry. If I can find V1, I will already know what's my Vp. And my Vp is the same across here and here. So that's how I can find this. So let's now look for what's my Vi. What's my potential difference across this resistor here? So V is equals to IR. My current is 2. My resistance is 5. Correct? So that gives me 10 volts. So in this column over here, ready? In this column over here, that's 10 volts. My total is 40. What would be my potential difference across here? Well, I do know that VE is equals to V1 plus VP. My VE, my total is 40 volts. I just found that V1 is 10. So that just tells me that VP is equals to 30 volts. All right, so that is my answer. So VP is my potential difference across my parallel arrangement. So whatever it is across here, it's the same across here. It will all be the same. So therefore, V3 is equals going to be 30 volts. There you go. Right? That's one way of solving it. There's probably many other ways of solving it, but this is one way you can solve it. Okay, finally, let's go to the last question. It looks something like this. That looks a bit weird. We don't usually have our batteries on this side of Dry's house here. This arrangement looks very funny, correct? How can we redraw this? How can we write it in a way which looks familiar to us? So that's one of the things that you need to, that's one of the strategies, redrawing it. Okay, so right now, let's redraw this diagram. Let's see how to do it. Okay, so let's first start with our power source over here. Okay, let's start here. So I know that this is 76 volts. Okay. Now, simply because I know that current goes from positive to negative, I'm going to start this way here first. Okay. And I'm going to draw it here like this. Okay. Now, so for all the drawings that we had, we usually have our components down here. So just for simplicity and for familiarity, I'm going to leave all my components at the bottom rather than the sides because it helps me to see very clearly my series and parallel. Okay, so what I get first? I have R1. Is it in the main or split path? This is in main path. So I have my first thing over here. That's R1. That's R1. I know it's 8 ohms. Okay, great. Then this happens. What happens over here? It will, class, it will split, right? It splits here and there. So let's draw our split. Oh dear, wrong color, sorry. Let's draw our split over here. Let me move it up a bit. Let's draw our split. It splits into two parts. Okay. Let's assume that this one over here is this path, and that over here is this path down here. Okay, so my first path, I know that I'm going to hit two resistors. Right? You see that? This one here, it hits two resistors. Right? And my two resistors are R2 and R3. In the bottom part, I get my one resistor, which is my R4. Now, before I add in the details, just to finish it up, these two split paths combine again to main path, right? This path and this path, they combine. So let's combine them. So now we're here, right? And it will meet R5, which is in the main path. R5 in the main path, and finally returns back here. So let's do that. Okay, so what I just did is I redrew everything in a way that looks familiar and easy for us to solve. Okay, I'm going to pause it here. I'm just going to fill in all the details which you'll see in the main diagram. I'm going to transfer it down to this diagram. All right, I've written down the resistance, but I wanted to go through the current and the potential difference with you. Right here, this over here, and this one over here. Okay, so this over here, this 4 amperes, does it belong to the main or split path? Main path, split path, right? So I need to draw it correctly into the path which it actually is in. 4 amperes. Now, short discussion. This is 4 amperes inside the split path. The main path is not 4 amperes. It's something else. It's definitely going to be something that's more, right? Because this and this makes up the main path. So this 4 amperes only belongs to this path here. Okay? Second thing I want to talk about is this over here. It tells me that my potential difference across my my resistance 4 resistance is 16 volts. Now, is that to say that the whole thing is 16 volts? The answer is no. Across this split path here, it is 16 volts. Now, where does that transfer here? Now, I'm going to shade it to show you where the 16 volts actually is. The 16 volts belongs here. And if by saying that it belongs to this path down here, I'm actually saying that the whole column here, right, from here to here, from here to here, everything from here to here is 16 volts, which is to say this is 16 volts. Okay, so I want you to be able to understand and recognize how that translated to what we've understood concerning my series and parallel so far. Okay, okay, so with that, we can start solving this question. What is the question asking you for? So there are three questions for this. Firstly, what is R2 equals to? What's this resistance equals to? Secondly, what is my current in the main path over here equals to? And lastly, what's the total resistance? If you can, you might like to pause it and try to solve it yourself before watching this video. Okay? So what I do have is I have a suggestion of how to solve this. There are many ways of solving it. There are many more elegant ways of solving it. There are shorter ways of solving it. This is my way of solving it. Okay? So what is R2? How do I find R2? All right. So R2 is found over here in this split path. I know my current going through this. I do not know my potential difference going through this. I also do not know the resistance. That's the question, right? Wait, is the potential difference going through this over here, just this part over here, 16 volts? Is it? The answer is no. Across the entire thing is 16 volts, right? How do I know that? You see, R4, this is 16 volts, correct? So inside this column, oh dear, what just happened? Oh dear, inside this column over here, this whole column, right? Everything inside this column here is 16 volts, correct? So this is 16 volts. This whole thing is 16 volts. This is not 16 volts, okay? But I do know that these two are in series, correct? So whatever potential difference here plus potential difference here will be equals to 16 volts. You see, this one over here, I know my resistance. Do I know my potential difference here? I don't know. But hey, what I do know is that I know that my current going through this will also be 4 amperes. How do you know that? Because this is in series. So whatever current is here, with the same current going through here. All right. So let's do that. I know that current is 4 amperes, resistance is 1 ohm. What can I find? 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 Oh, I can find the potential difference across this, right? And I know and I remember that the total potential difference will be this and that, correct? So let's use that. So now let's find what is the potential difference across resistance 3. So V3 will be equals to the current flowing through it, which is 4 amperes, multiplied by my resistance, which is 1 ohm, 4 volts. Nice. So what is then my potential difference across V2? Well, I remember that V total is equal to V1 plus V2, correct? That's what we did just now, right? Which looks something like this, right? Or VE, or V total, VE, okay, same thing. It goes to V1 plus V2, which is V1 and V2, right? Whatever this here, whatever that, all the things inside this column and all the things on that column will add up. So that's as good as saying V2 is equals to the total, which in this case is 16 volts, minus, what am minus? This part over here, right? That would be 4 volts. Okay, now if that confuses a bit, right? Instead of writing this, I could have written 16 volts is equals to V2 plus V3, which in actual fact, which you found, 16 is equals to V2 plus 4. That's why I have this. It gives me 12 volts. Nice. 12 volts. All right, so now I know that this over here, so let's put it inside, okay? I know 12 volts, right? I know that my V2 is 12 volts. For this component, I got my I got my V. Let's find the R, right? So what is R? Resistance 2 is V over I. So that's 12 divided by 4. I have 3 ohms. Sweet. Okay. Now, I have solved the first part. Now I'm supposed to find what is my current going through the main path over here. What's the current going through here? Can I find it? Oh, do I find my total resistance? Can I do that? I could. You see, because to find the current in the main path, I'm basically asking you for what is the total resistance and what's the total potential difference in the whole thing, right? I could do that, but there's also an easier, more elegant way. Now, look at this. Where does this current come from? The main path current comes from what's inside here and what's inside there, correct? So I know this is 4. Do I know what this is over here? What's the current flowing through R4 in this other split path? Now, remember here, do I have 2 or 3? Let's see. I have resistance, I have potential difference. Oh, I have resistance, potential. I can find I. I can find what is the current flowing over here, correct? So how about that? Let's find what is the current flowing through resistor number 4. Let's do the working for that. So it's getting quite messy here. So this one was solving for what is R2. Okay, now let's bring this one over here and let's erase this away. Okay, so what is the current flowing through? So now I'm asking for what is the current here, right? What is the current flowing through R4? So I4 over here is equals to, what's the formula? How to find I? V equals to IR, I equals to V over R. All right, please be comfortable doing this. So potential difference across resistor number 4, and the resistance of resistor number 4 is 1 ampere. Oh, cool. I know that this is 4 amperes and this is 1 ampere. So what will the main path current be? Oh, that means I is equals to 4 ampere plus 1 ampere. Actually, I don't need to write this one. Equals to 5 amperes. I think this is a much easier, more elegant way of solving it without looking for the total resistance, because that's actually this over here, correct? So finally, how do I find total resistance? Now I'm just wondering right now as you watch this, are you thinking about this, find all of this, simplify everything and add everything up? Is there a better way? Now, I will do both ways for you right now, but I'd like to show you that there's a faster way of doing it. The fastest way, of course, is total resistance is total current over total potential difference, correct? Do I have total potential difference? Do I have the EMF? I have. This is the total, right? Do I have the total current? Yes, I do. Is this one over here? That's the total current. So actually, without finding the resistance the way we did up here, right? I could actually just find it by doing R is equals to V over I. That's 76 divided by 5. And the answer will be, calculator, don't fail me now, 15.2 ohm. Could we solve it by looking for all the resistors and adding it up? Absolutely. And that's something that you should try to do. Okay, so I'm not going to do it in this video, but the general idea is, series, whole thing in parallel, this part is series, this and these are in parallel. So I will simplify this. This would be, what's my R2? I solved it just now. R2 is 3 ohms. Oh, I did something very wrong. Every time I finish solving something, you should always write inside whatever you found. And what I did find is that this is 3 ohm. Yeah. Let me get a bit faster. This and this, what we get? 3 ohm, 1 ohm, we get 4 ohm. This is 4 ohm, this is 16 ohm. This would be 104 plus 1 over 16, correct? By the 1. And then this over here will be in ohms. And this over here, because it's a series, right? 4 ohm. You understand what I mean by a series? Okay? This should give you the same answer as just now. Okay, this has been a very, very long video. But I hope that through doing these examples, you can see better how we're supposed to use all of the rules to solve things like these. Okay, all the best, guys.